This video will hopefully be a quick illustration on the effects period number has on electronegativity. This is our data table. We determined that the lower the period number, the higher the electronegativity value. This means that the further up you go on the periodic table, the higher the tendency of an atom is to attract another electron, and we'll illustrate this more later on. The electronegativity number is the measure of an atom's ability to attract electrons. This property decreases as atoms get larger because electrons move to shells further away from the nucleus, decreasing the attraction between the nucleus and the electrons. Atoms want to have 8 valence electrons, and having 8 valence electrons seems to make them a very stable element, as seen in the noble gases. Atoms closest to and below 8 valence electrons are said to have very high electronegativity. For example, in period 1, the atom's high electronegativity is because its valence electrons are so close to the nucleus. This gives them a higher electronegativity property than, say, other elements in other periods. Alright, so here's a little GIF illustrating the concept of electronegativity. Now remember, fluorine here has the high electronegativity. Remember, it's on the very right of the periodic table. And Na is on the very left, so it has very low electronegativity. And as we'll see, as the video can never load, Na goes to fluorine, and fluorine steals its electron. Now, fluorine has 8 valence electrons. And here's the 8th electron. This electron is going to fluorine because fluorine has high electronegativity. Fluorine is high. Alright, so here's an image that I think really illustrates the whole concept of electronegativity on the periodic table. If you notice, the noble gases here on the right-hand side are missing because they already have 8 valence electrons. Their desire to attract another electron from any other element is basically 0. They're perfectly content with their 8 valence electrons. They don't want any more, and they don't want any less. Then, of course, we have the total opposite, which is fluorine, that really, really wants to attract another electron. This is because its valence electrons are only in the second period. That means they're very close to the atom, and I think I'll draw a picture here illustrating it for you. Its valence electrons are only in the second shell. They're super close to the atom, so they really want that 8th electrons in order to become a stable, good, healthy element. This, of course, is pretty opposite to these guys over here, all the way on the left. These have very low electronegativity values, Li through Fr. This is because in order to get to 8 valence electrons like the noble gases have, they would have to travel all the way across the periodic table of elements just to get to 8 so they can be a stable element. However, what would happen if they just lost an electron? Then they would be right at 8. Well, this is precisely what they want to do. They want to just lose 1 electron because elements are lazy. And when they lose this single electron, they're said to be ionizing. This means ionizing just means losing 1 electron. And then they'll be right here at 8 valence electrons. So if, say, lithium and fluorine, the lowest and the highest, lithium having a very low electronegativity value, and fluorine, of course, having a very high electronegativity value, lithium will want to give away its electron, and fluorine will want to take it. So let's say we have lithium, and they go together. Well, fluorine's going to take this little lithium electron, and it's going to add it to its own collection. It's going to put it in its own pocket, and then fluorine is going to be a perfectly happy element, and it's going to be right along with the noble gases and be very stable and very happy. Alright, so that is our PowerPoint on the concept of electronegativity. Hope you enjoyed.